So here in example number 1, if I want to find the shortest distance from one point to a line, well, the best way to do it is to at least draw a picture first. At least you have something to look at. And that probably will save you a lot of time thinking about it in your head and missing one point or another eventually. So first of all, they have a point at -1 and 3. Here is a point P, with its coordinates given to us. And here we have a line, y equals -x plus 5. This is a line that we can draw without a calculator. We have the slope, we have the y-intercept. Y-intercept at +5, and the slope is -1. Down by 1, run by 1, and as you continue with the same pattern, we will have a line created by these points. So if I want to draw a line perpendicular to it that goes through the point P, this line will make a right angle with the line given to us. And the reason why we are creating this perpendicular line is to come up with this coordinate. This is the point where those two lines intersect. We have the equation for one of the two lines. -x plus 5, this line is given to us. But for now, we don't quite know the equation for this line. We need two equations to solve a system. What do you know about this red line? If these two lines are perpendicular, the slope, if the slope for this blue line is -1, the slope of this red line will give us negative reciprocal, or in another word, I will have +1 for the slope. And knowing we have this line passing through the point -1 and 3, if we have a point at -1 and 3 for this red line, I can now create the equation of this line using slope point form. Y minus y1 equals m times x minus x1. This is something that we did back in term 1. We have the x and y coordinate for this one point, and we have the slope as well. We have slope equals 1, and we have the x coordinate and the y coordinate. I have x minus x1, and on the other side, y minus y1. So after you simplify it, I have x plus 4, y equals x plus 4 for this equation. And if you check with your graph, it does seem like I have the y-intercept at 4. Now, of course, if you are to do it with a graph paper, it will save you a lot of time to identify this y-intercept and have slope-intercept form instead. But given I don't have a graph paper here, I use the slope point form instead. And now with the two equations here, I can now solve for the point of intersections. I can do it by substitution or by elimination. Having these two equations equal to each other, negative x plus 5 equals x plus 4. One equation here, one equation there. And knowing how both of them equal to y, both of them are equal to y, I can set them equal to each other and solve for x. And once I have the x coordinate, I can now calculate the y coordinate. And once I have the coordinates for this point, 0.5 and 4.5, I can now calculate the distance between point P and this point of intersections using the distance formula. With negative 1 and 3 for the other point, I can now calculate the distance. Here is the distance formula. Basically, it is the difference of the x coordinate, the difference of the y coordinate. You square each of them and solve it. So here under the big square root, the difference of x from negative 1 to positive 0.5, I have 1.5 for the x coordinate. And for the y coordinate, from 3 to 4.5, the difference between the two of them is 1.5. So now, square the numbers, take the square root. Here is the shortest distance between the point and the line. You simply use your calculator to do it. Square the 1.5, add them together. That gives us 4.5 in the square root. And of course, you can use your calculator again. Take the square root of 4.5. You probably will end up with 2 point something. Like 2.2? Approximately. I don't have my calculator here.